Morning, dear student. Very warm welcome to all of you in today's session. Today we are going to discuss about chapter 7, section 4. So in this case, we will discuss the very two important topics. The very first one is empirical formula, and the second one is chemical molecular formula. Now, what is the difference between empirical formula and chemical formula? This is what I'm going to teach you today now. Just if you go through this one, the very first one that is in front of you is about empirical formula. This worksheet is the SALT worksheet. It is attached in the folder. You have to go through it very carefully, and I will discuss the empirical formula with one example over here, and after that I will give you one quiz at the end of this sheet. You have to solve it, and then you have to submit it in Schoology. Now, just what is empirical formula now? We learned about many sort of formulas like structure formula, a ball and stick model of different sorts of compounds, the molecular formula, formula unit, many things we learned. Today we are discussing about empirical formula. And empirical formula shows the simplest whole ratio among the elements present in a compound. For example, a compound is made up of two or more than two elements. Same element, different elements will be there now. So in order to take all those elements into a simple whole ratio, we call it an empirical formula now. There are many methods in order to convert, in order to determine the empirical formula of different sorts of compounds, but the very first one is determining the empirical formula from percentage composition. The word percentage composition is very important here now. Look, dear student, as you know that at the end of the section review of the chapter, you will see that there are many questions where the percentage composition of the element present in a compound is given, and then you have to find out the empirical formula of those compounds. So how you can solve it, it needs some sort of steps now. The steps you must follow accordingly. Whatever is mentioned over here, you have to go through it properly now. If the percentage of the element in a compound is given, you have to follow the given steps. For example, the very first question that's mentioned over here for your guidance state, the percentage composition of 100% diboron. We have a compound. The name of the compound is diboron, and it's 100% with us right now. Now, the information given in this question is that this diboron is made up of 78.1% of boron and 21.9% of hydrogen. Now, only these two things are mentioned over here. It should be clear to you right now that diboron is made up of two elements, boron and hydrogen now. Now, the boron is almost 78.1%. Again, repeating, it is in percent, it's not in gram, it's not in mole. And same for hydrogen, it's also in percentage now. The step one is that you have to convert the percentage composition into mass. If you want to convert the percentage into mass, how do you convert it? As I told you that we have 100% of diboron. And this 100% of diboron contains 78.1% of boron and 21.9% of hydrogen. So if we have these one in percentage, when you will convert it into grams, look, 100% means we have 100 gram of diboron. It consists of 78.1 gram of boron and 21.9% of it's 21.9 gram of hydrogen now. Now, dear student, you converted the percentage into grams by putting gram in front of the values right now. Now, the step two is that you have to convert the masses into moles. In the previous lesson, we learned it, how to convert a masses into mole or mole into masses. So in order to convert the number of you have to find out the number of moles. Then we have the formula is that is given mass divided by the molar mass now. The molar mass you can find out from periodic table. If it is a single element, like boron is a single element, you can find out the atomic mass of boron from the periodic table. That is the molar mass of boron. Same for hydrogen now. Now the given mass of boron in the question is that it is almost 78.1 gram. This is what given in the question right now. And its molar mass according to the periodic table, if you go through the periodic table, you can see that it is 10.81 gram now. Same for hydrogen, the given mass is 21.9 gram, while its molar mass is 1.01 gram per mole now. Now we have two things the given mass in the question and the molar mass you can find out from the periodic table now. When you will get these two things, you have to put it in the formula that's given over here. If we want to find out the number of moles of boron, it is 78.1 divided by 10.81. So you will get 7.22 moles of boron. Same for number of moles for hydrogen. If you want to find out, as you know that we have a given mass that is 21.9 gram divided by its molar mass, it is 1.01 gram, and you will get the value 21.7 mole of hydrogen now. Now the question is that if we will get these two values now, the question is that is it these values are enough to give us the empirical formula for a compound? The answer is no, because when I started the lecture about the empirical formula, I told you that it should be in the simplest whole number. It should be not in decimals. These are in decimal. It should be in small whole number. Now, if these are in decimals, so we have to go towards the third step. It is about divide the number of moles with the simple ratio number. We have two numbers over here now, 7.22, 21.7. The one that is the least, you have to divide the least with both of these two. So 7.22 divided by 7.22 for boron, and 21.7 divided by 7.22, the least one you are dividing with this one now. When you divide these two, you will get 1 mole of boron and almost equal to 3.01 mole of hydrogen. So over here, we will round off these two values, consider it 3 only. So it means that we have 1 mole of boron and 3 moles of hydrogen. So the empirical formula for a compound would be B1B and 3 hydrogen BH3. So now this one is the simplest whole ratio of diboron. This is what we call it the empirical form. How to find out the empirical formula by going through different sorts of steps. Now, dear student, when you will focus, when you will go through all these things, at the end, you have to solve this one, okay? And you have to attach the answers. Whatever you are going to write, you have to print it or write it. Either you can use your soft copy and then you can submit it into the Schoology. I will go through it. Now, the second part is about molecular formula mass or molecular formula. We learned about empirical formula. What is molecular formula? The difference is that empirical formula tells us about the simple whole ratio of elements in a compound, while molecular formula gives us the actual number of elements in a compound. Actual number means the exact number of elements present in a compound now. Now, if we have to find out the molecular formula of any compound, we have a formula like this one. X into empirical formula is equal to molecular formula now. This X over here is a whole number always. X is always a whole number. So in this case, how we can find out this this molecular formula? We will go through this one. For example, in case of diboron, what we learn right now is, you know that the diboron consists of 1 boron and 3 hydrogen. So the molar mass of diboron will be 13.84 U. Okay, but the formula mass is given for diboron. It's given already. It's 27.67. This one will be given to you in the quizzes, that we have a formula for mass for diboron is 27.6 U, but you have to find out the formula mass for the empirical value. Sorry, the formula mass of the empirical formula, it's almost equal to 13.84. So X will be molecular formula divided by empirical formula now. X will be molecular formula mass divided by empirical formula mass. It is almost equal to 2 now. When you will get the value 2, the value is 2 over here. Now put the 2 over here now. So the 2, when it will come here, as you know that the formula for diboron is BH3. So 2 into BH3 is equal to, you will multiply this 2 with both of these two values. So B2H6, 3 into 2 is equal to 6. So the molecular formula for dibromine is B2H6, while its empirical formula, we already find it out before, it is BH3. I'm going to share 2 slides as 2 assessment sheet in the day 1 week 10 Schoology Forum. In the first assessment sheet, you have to find out the empirical formula of the compound. In the second one, you have to find out the molecular formula of the compound, the given compound. Make sure that there is a guidance in each and every assessment sheet. You have to go through it very carefully, and you have to complete it. And after completing this one, if you have any question in the section reviews, over here in the section review, you can ask the questions in the discussion forum in day 1, week 10. Have a nice day. Thank you very much, dear student.